ఇప్పుడైతే ఓపెన్ చేయండి, నేను ఎక్స్ప్లెయిన్ చేయాలి అది.
So you are typing in Google Colab, right?
Because I have to switch the network.
So that's I think we can use this notebook directly.
Yeah. Or what I thought is we can, I have the notebook downloaded, then I have to run the Jupyter notebook and then open it. Exercise 3. Oh yeah, exercise 3, right. So this is what you should see at your end. This is day 2, exercise 3. I have this diagram just to indicate that we are dealing with single neuron. And then I define what are the activation functions you are supposed to use. So I am defining the weights and data and bias also that you have to set. What should be the value of weight, data, x1, x2 and b. And variable names are depicted in the diagram above, so make sure you're using the same variable names. And the final output should be stored in O. And I mentioned again that you don't have to use f of x plus h minus f of x by h. And how is this validated? You have this draw dot function and other related functions. Now the value class is completely empty, so you have to fill it with the correct data, with the correct code, and initialize all your variables. I think you did this yesterday, so you know the steps, right? And if you're confused like what is expected, you can take a look at the test case where the assertions are. We deliberately made it visible so that you know what exactly are we asserting. We have labels for all this, weights, biases, and some internal variables, intermediate variables, and the labels, corresponding labels for these intermediate variables. And n and the final output. So you can see we are not rounding off the values. We are using the complete value for assertion, hoping that there will be lesser issues today. And what else is there? Some guidelines on how you can start coding from here. So each cell, I've given you the comment, what you have to calculate, and the first cell is a sample, right? So O with respect to O is set to 1. That is where you start, the rightmost node. And then you set O dot grad equal to O with respect to O. And we are asserting the same here. And from the next cell onwards, I've given you, to simplify the work, I've given you the variables already. So that if you're copying, it becomes difficult. So that's the reason in the commented section, I'm giving you the variables. So uncomment that, use it. And how should you set this value? You know what is the derivative of the activation function. We spent a lot of time on that. So use that formula and then set the values. And similarly for the next cells also. So this was with respect to n. Now derivative of output with respect to this intermediate variable. So this is the value you have to set, and this is the gradient that you have to set. So make sure you're using the same variables. Don't change the variable names because the assertions will fail. And finally, there is a draw dot of O just to verify if all the gradients are set correctly or no. And if there's any doubt, you can use draw dot O in the intermediate cells also. So it will help you in debugging your code quickly.
I'm actually getting confused here now. This part, this is O with respect to O means we are changing the value of C.
Yes, you can put it as O. Actually, I should have used O, but then I forgot. O is output.
Okay.
So now Should be easy to understand.
So once we are changing the value of O, it will become near to 1. The gradient will become near to 1 with respect to O again.
Yes.
Then once we are changing with respect to A, we are getting it as 3.
In case of multiplication.
And in case of B, it is coming as 2.
Yes.
And then once we calculated all the gradients,
You have to assign the gradients.
yes ma'am. But then you said the plus operator will have the same
Yes,
gradients
yes.
transmitted. But then if we use multiplication, this will change.
Yes.
But how can we check the value of plus with these both now?
Value of plus?
If we use plus here, it should be 1 1 here. But then once we are assigning the values 3 to 1.
So manually it is difficult to check. But we'll also discuss automatically how we can calculate all of this.
Okay, so we don't need to know that how it does automatically.
This is only for the theory, so that we get to the actual automatic process. So you understand manually, automatic process will be easy to understand.
Yes.
Yeah. So verification is your question, right?
Yes, ma'am.
Yeah. Don't worry.
Okay.
So that will be sorted in automatic backpropagation. Yes.
I understand how you're not matching the values.
You did not understand.
Yeah, you're putting it manually.
Hmm.
Okay, then with respect to first you're doing with O. And then you're putting A and BC as one graph.
No. Individually, I'm calculating the gradient. First with respect to O, then with respect to A, then with respect to B.
You wrote one more function on it.
Yes, the same function.
It just kept equal to 1.
Initially, yes. That is after calculation.
After getting O.
Yes.
Then I do with respect to A then.
Yes.
Then B.
Yes. I copy pasted the code because I didn't want to type again.
And then that's so confusing, so we got confused.
Okay. But is it clear now?
Yeah, just try asking.
Okay.
So whenever you are trying to discuss,
If you are getting the label, grad, how many of you are not getting the grad visibility? Please raise your hand. Grad. Only 1, 2, 3. But I saw nearly 14 to 15 people. Only 3. Okay. I'll come back. You're not getting it.
Just showed. I think some of you could not follow because you were not typing or something else. I don't know what was the issue. But there were 3 things that we did in the live code example that I showed you. First, we calculated derivative of the output with respect to itself. That was the first cell. So in that case, I'm nudging the value of C, that is the output. Now in case you're getting confused with C and O, then you can just replace this with O. In that case, all the variables will have the same name, right? You can do the same thing. So every time I'm nudging the value of the variable with respect to which I want to check the derivative. So the first cell had derivative of O with respect to O. So that's the reason I'm nudging the value of O right? This is also O, in case you're getting confused with the variable names. Output. So we are nudging the value of output. We are checking what is O with respect to O. It is 1, right? That was the first cell. Now coming to the second cell, we calculated derivative of the output with respect to the variable A. And for that, I nudged the value of A. This time, the nudging of the value should happen before I calculate the output. So you can use different variable names in case this is not convenient to you. You can use some other variable names too. So whenever I wanted to calculate the derivative of O with respect to A, I was nudging the value of A slightly because I want to know the rate of change of my output. That was the second cell. Now coming to the last cell or the third cell, it is derivative of O with respect to B. Again, to simplify, I will replace this with O. This also with O. So it becomes clear to you, and O. So nudging the value of B slightly here. And then I calculate derivative of O with respect to B. This is the third cell. Now because my math equation is quite simple, I have only two variables here, that is A and B. And derivative of O with respect to O doesn't actually have any value, because it's eventually the prediction. You won't be changing the prediction in case of a neural network. You will be changing the intermediate values in the layers of the neurons. The different layers that you have in the neural network, you will be changing the values there. So those are more important. So derivative of O with respect to A and derivative of O with respect to B. These two are quite important. And we also understood how the derivative, how is the gradient getting impacted if I change the math operator. In case of multiplication, the gradient flow is not same as in the case of addition, because the proportionality changes. So you want me to switch?
What's the time?
20 minutes.
20 minutes for this. right? Yeah, Sripooja, can you just give a hint and if you can code a little bit regarding tangent?
Code is not needed actually. Code in one cell will unblock you completely. So most of you are stuck at the cell n. What should be the gradient of that value? And yesterday you spent time in calculating derivative of tan h. So what is the formula for that? What is derivative of tan h? 1 minus tan h square. So can't you use the same formula there in that cell? Yes or no? So you put that n value and then you will have chain of values to be followed, right? We discussed clearly, if there is a plus operator, your gradients flow back. Using the same logic, you have to compose the other cells also, calculate the subsequent values. Right side, rightmost cell, you know the gradient is 1. The next gradient is 1 minus tan h square, n dot grad. So once you have n dot grad, can't you calculate the other values? Manage formula e power 2x minus 1 by e power 2x plus 1. So if you're using e power x minus e power minus x, the last decimal value will not match. That's the reason I put it on the slide while explaining the question. And use math.exe.
After this, we need to use backpropagation and use derivatives and all.
Yes.
After, so now with respect to n, so we need to use
టెన్షన్ ఏం లేదు సార్.
Who is next square? Very good. Going forward, please follow the approach. Okay?
One minute, sir. I'm adding it to the slide. So this is the only cell where you're stuck at, that is n, right? So O with respect to n is 1 minus tan h square, right? So you get that value, you can use the same value and the other subsequent values. So you keep chaining the values together to arrive at the final solution. So this is one cell where you're stuck. So I give you the solution here. It is O with respect to n is 1 minus O dot data whole square.
Sripooja, can you zoom in a little bit? Yes.
Right? So this is for O with respect to n. Now I'll show you with the help of diagram. So this is where you are. This is the rightmost node, which is 1, quite trivial. Now tan h is there. So derivative of tan h is what? 1 minus tan h square. So using that you got this value, 0.0218, right? Now what is there before this? It is a plus operator, right? So your gradients flow back. Just one step, guys, one step you do it, the other steps will be solved. And draw dot is there to help you with the visualization. The solution? So this is the cell, this is the solution.
I hope everyone got it now, right?
And the next cell also I'll show you. N.grad, you can reuse the same values. You just have to assign once, reuse the same values again. Look at the graph, that's the reason I'm telling you. You should understand how the gradients are flowing. You should understand how they get calculated. Assertions are passing?
Yes.
Huh. Print is not needed. Print is only for you if you want to see. Audio off చేసారా
take into that account, and we are going to show you a solution. Look at it, understand, and ask. Okay, so you can just switch the.
Yes.
Question yourself why you are not getting it. What was the problem? This is a good way of learning.
So there are two issues here that I have noticed with most of you, the way you're implementing it. TANH, you're not implementing it as a class method. So the final node, the output node doesn't have children. So you're not able to generate the graph. So that is the first problem. So you have to implement TANH as a class method. Then we address the next problem, that is calculating the gradients. Right? So once this graph is generated, then you start here. O with respect to O is initialized. Then I told you the derivative of tan h is 1 minus tan h square. Using that you can initialize O with respect to n. Then you set n dot gradient as O with respect to n. So now you have the value. Now you have to work from right to left in the graph. And that's the reason I included one cell here to check the draw dot, how it's working. So if you look at the graph, you will understand how you can initialize the values. Now this is not initialized, but still I can understand that the gradient of n is 0.0218, right? Now with the plus operator, I can easily know from the graph that now the values, the gradient values for B, W1 x1, W2 x2 will be same as n dot grad. Correct? Up to this point, is it right? Plus operator, gradients flow back. Now you have this level of gradient set. What else is there? Again a plus operator, meaning the gradients are again going to flow back, 0.0218, the same. So whatever was initialized here will get initialized here as well, the plus operator. So you use the gradient from the previous cell, add it here. Now comes the tricky part, that is multiplication. So if you look at the graph, I told you it is going to be crisscross. So just say for gradient of W1 will be x1 data into gradient of the previous cell, that is W1 x1. Put that math formula there and you can calculate the gradient of W1. And so for x1, x2 and W2. Use the crisscross method. I'll show you that formula as well. So here's one example. W1 x1 gradient into x1 data. This is for the leaf nodes, the final ones towards the left, the leftmost gradients. So W1 grad is this, W1 x1 grad into x1 dot data. And similarly for the last cell as well. You swap the values and then multiply. And finally, you should be able to see this graph where all the gradients are set correctly. You start with 1, set this derivative of n, which is 0.0218. The same values flow back because of plus operator. Again, the same values flow back because of a plus operator again. But here, eventually, this gradient gets multiplied with the data here and gets initialized here. So multiplication will be slightly tricky. If you look at the graph, you will understand it. So you were stuck basically at one point only, that is derivative of tan h. And the child nodes you have to implement as a class method, then you will get the child nodes in the graph. as a class method. Here, take a look at this code. If you're not able to generate the graph, you're not initializing the children of a node. So use tanh here as a class method. Then it should work. ఇప్పుడు ఎంతమంది సాల్వ్ చేశారు?
to the grading. You're directly assigning an average value to the resolving which answer.
So if they write everything correctly here, this assertion, all these assertions must pass. After this, we have a dot function. Yeah, so using this, they can visualize easily, right? After that, this is already, yes, this is already initialized for them. This is already initialized for them, the first one. Here I provided the variables they are supposed to use. They need to insert this value here. Yes. So they are not able to understand what value to put it there. After that, it's just reusing the values. Once they get that n.grad, everything is done.
Getting lost. Simple. Some of you are just not getting it into your head. See, O with respect to N, what is it? She has already told you how to take the derivative. That is what is N. N is the output of the activation. N is basically after the activation has been applied to O. So, your O is given. N has to be computed. How do you get N? Just before applying activation, what is it? So you have to pass the derivative back from O. So what will you write there? O with respect to N is derivative of tan h. So what is derivative of O with respect to what is dO of dn? 1 minus tan squared h. No. So what do you need to do? You have to apply that backward. So the derivative of O with respect to n, the gradient of O with respect to n, you know. That is the same n dot grad. Once you know n dot grad, go further down. There is W1 x1, W2 x2. Are you doing anything to this to get to n? Show them this is correct one.
ఇది కరెక్ట్
O with respect to n is 1 minus tan squared h.
ఇది 100 రాలేదా? Then they need to reuse.
This is n dot grad, it's as it is. So basically W1 x1, W2 x2 is a placeholder for n. Same thing, you are getting it back. Then go with respect to B. You are coming one step before. I think
With the
draw the equation and show.
this one
This is the equation.
or
Where is A and where is
1
B?
minute in the
There
end.
is no A, no B, no.
This is O, this is N. Then we have B. This
Here B is there. Just try to compute the gradients backwards. We only want the gradients on each value. Acha, be clear what are the cells. The outermost cell is O, whose value is already given. It can be rounded or corrected, whatever. Then, how do you get N? How do you get the cell N? How did N come? Or rather, N's data you know, the gradient has to come back. Data is there already.
N is W1 x1 plus W2 x2
x1 plus W2 x2
plus
B.
B.
That is N.
Then we have applied tan here.
And gradient is coming back. That gradient is coming from tan squared h. Because it's plus, the gradient flows back into B and W1 x1 plus W2 x2. W1 x1, W2 x2, again because it's a B, it flows into W2 x2 and W1 x1.
They used a wrong operator here.
No, that's wrong. That is multiply then.
Yeah.
See, W2 x2 comes from W2 and x2 by multiplication, not by addition. This chart is wrong. Same way with W1 x1.
They did not generate.
No, show one test cell which is correct. One solution which is correct now.
Yes, sir.
Yeah, let's look at a solution which is correct done by one of you.
Hopefully.
So this is what it should look after it's computed.
This is correct.
So let's look at the cells. No, not this. Computation.
Okay.
Okay, here starts n. See, this is the way n is computed. Now, what this person has used is
tan h square.
The formula for tan h. 1 minus tan h squared. You can also use the between tan h. Then you set n. Now from n, we go back to w1 x1, w2 x2, whatever it is. So if the gradient is the same, n is nothing but w1 x1 plus w2 x2, not different. There is no computation in between. So it goes as it is. Now the gradient with respect to b
Is also the same.
is n dot gradient because
Plus operator.
w1 x1 plus w2 x2 plus b is n. So obviously the gradient of n with respect to b will be what?
It will be n dot grad.
Whatever is there will flow back. Yeah. Then now with respect to w1 x1, w2 x2, we are getting with respect to w2 x2. What is it?
Whatever was here.
Whatever is the gradient will flow back because of the plus. See, the gradient is equal. W1 x1, W2 x2, gradient is coming back as it is. Now, for here, for gradient with respect to W2 is W2 x2 gradient into x2 data. That is the switch because of the multiplication. So that is how W2 gradient gets computed. Then similarly, with respect to x2, will be W2 x2 into dot gradient into W2 data because again of the multiplication switch. Then same thing happens with W1. It's W1 x1's gradient multiplied with x1 dot data because of the multiplication. And then you have the same thing while computing x1 gradient, you multiply with w1's data. Yes. That's it. That's all. And you're done. See, when there is only smart thing to do is this tan h. After that, see, because of the plus sign, whatever gradient is here flows back. Plus sign. Plus sign doesn't change the gradient. Because if you have a plus b, c is equal to a plus b, dc by dA is what? 1. So same gradient goes. dc by dB is also 1. Same gradient goes. By chain rule. See, there is implicitly chain rule. The gradient is flowing back either by plus sign or by multiplication sign. That's why the gradient is flowing back. The chain rule is in action. You know chain rule? Oh yes. So that's what is happening. It is flowing back. Evaluate again. They must get this.
Most of them got.
See why this is important, I will tell you. You may be thinking we are pulling teeth here. No. This is the basis of tensor. You don't understand this, you will never understand tensor. Because the whole of PyTorch, instead of value, will be using tensor. And you should be comfortable with the flow of the gradient backward and forward. There is no forward, there is only backward. how gradients move backward. You should understand it implicitly because the whole of tensor arithmetic is based on this. Only thing is it will happen automatically, you won't know. But you will have to understand what's happening. Value is nothing but tensor. Today it is value, tomorrow it will become tensor.
29.
Hey, come on. Do the computation. The equation you know. O is equal to N is equal to W1 x1 plus W2 x2 plus B.
వీళ్ళకి నోట్బుక్ రిజిస్టర్
calculated, then W1 x1, W2 x2 is calculated, B is calculated, W1 x1 goes backward,
ఇప్పుడు రిజిస్టర్ చేయాలి నోట్ ఎక్కువ ఉందా
lands at it, W1 W2
ఎక్సర్సైజ్ కోడ్ ఇచ్చేసి రిలీజ్ చేసేద్దామా ఈ కోడ్ సొల్యూషన్
Still are teaching idiots. Only idiots
the older notebooks somewhere. From home, you are not able